piece stuff, but I can record this. All right, cool. So here are the answers. If we take a look, those answers are also on this week's calendar under check answers to the packet for Tuesday. So you can do that as well. I'm gonna go grab a drink of water. My throat, I can feel it getting dry. And then I'll come back and take attendance and move those around. This math is required for tomorrow's laboratory. So you need to make sure you can do it. All right, I'm going to move that up a little bit. The calculator here to brace it. Take a look at those answers. Sorry, my Wi-Fi is being slow. This is page 11.
Oh,
It may be a little bit different on yours. It may only go to 5. So this is page 11 and 12. Get this attendance real quick. We got the Buckleys. Tegan is in person. Lily Connor does a slow internet, but she's on. Ian is in person. Goldstein. Yep. Margot got on. She might be a robot. Braden. Braden is in person. Jordan. Jordan is at home. Gavin Lindsay. You're Gavin Rump, right? Yeah. Gavin Lindsay is at home. Allison. Allie McMaster. And Coco Hudson. Natalia. And the last ones of these. And remember, whenever you're looking at these, the coefficient is from the balanced equation. That's what goes down as either CB or CA. If it's not there, then that means it's 1. That's fine.
I have a question.
Yeah.
For number 1, are there, since there are 3 sig figs, would it be 0.0133?
Oh.
Or did I like?
Oh, there's only 2 sig figs here.
Oh, I miscounted that. Thank you.
Welcome. No, I thought I made a mistake there for a second, right?
same for number 2.
2 significant digits. Ah. Anna Reynolds is here. Sydney Ricketts is at home. Mia Rivas is here. Gavin Ralph is here. Olivia is here. Peter is here. All right. Cool. And the bottom.
Where was it?
Oh, you finally got me, didn't you? 0.3020 times 33.21 divided by 1.
It's about 10.
What is this? Oh, 20. 0.3020 times 33.21 divided by 20.
It's about 0.5014.
Finally got me on one. There you go. Good. Others?
When you make the equations, do you kind of just like, how do you like, I can usually figure out, but like, how do you know for sure that it's correct?
So the equation is mava over ka equals mv over kub, right?
No, I mean like the when you make like the balanced equation of to find out the coefficient number.
All right. So let's take, for example, HCl plus NaOH. It is a double displacement reaction. So we're going to have H and Na switch places. So that's going to give us HOH, which is H2O, and a salt with a cation and an anion. The cation here is Na and the anion is Cl. What is the charge of Na?
1.
1. So we look at that charge and we compare it to the charge of the Cl, which is
-1.
-1. So they cancel out, and then we would balance it based on this. If this were not +1 and -1, let's say that this is +2, like in the case of barium hydroxide, then we would put Ba here and Cl2. Then we would need to go and balance the HCl. So it's a double displacement reaction from last semester.
Okay, so it's always double displacement.
Yes. Yep. And you
Okay.
want one thing to form known as water. And the other thing is an ionic salt. This is actually the acid that we're going to titrate tomorrow. We won't know the HCl. We will know the concentration of the NaOH. So we just need to find the volumes of each. We get to choose how much HCl we use. A good amount will be 10 milliliters. If these were equal concentrations, how much NaOH would I need then? 10 milliliters. Okay. Hey, Ian, making it hard on me over here. So if we take a look, the NaOH would be 10 milliliters if we had 10 milliliters of the acid and they were the same concentration. Since these are both strong acids and strong bases, where do you think they neutralize at? What will be the pH at neutralization point, or what we call the endpoint? 7. For a strong acid, strong base, the endpoint is 7. Strong acid, strong base, the endpoint is 7. So if we take a look, this is the hard note part. This is the part that's going to make it hard for you in the lab if you don't know this stuff tomorrow, right? So if we take a look, we want something that changes at 7. So methyl violet will not work because it changes closer to 1. Thymol blue, it's got quite a big change here, but that could be possible to work. Methyl yellow is an indicator that changes down at 4, so that's not going to be good. Bromophenol blue, that's no good. Methyl orange, that's no good. Methyl red, it's close. Litmus might be good if we had some litmus. But look at this, bromothiamyl blue, right on there. It goes from yellow to green to blue. So that's probably going to be the best for us right there. And that's the one we're going to use. Phenol red, I've got phenol red, and we could use that as well if a group wants to use that indicator. Phenolphthalein, not so good. Thymolphthalein, not so good. And alizarin yellow, no good. So this is an indicator chart. You want the indicator that's going to be right at the pH of where it's going to change at. For us, it looks like the best one will be the bromothiamyl blue. So that's the one we're going to use. Now, if we are changing the pH at 7, tomorrow you guys are going to make a graph that's known as the titration curve. Take a look here. We are going to start with acid. The pH of it's going to be very low. And then right when we reach that neutralization point, boom, it jumps up to 7. And then as we add more and more acid, it goes back this way because, I'm sorry, as we add more and more base, it goes back to this way because the pH jumps up. And then again, it's going to level off to the pH of the base that you're adding. Here, we have mostly what? hydrogen ions or hydroxide ions? Here at the start? Hydrogen ions, right? We have a lot of H plus here. And then they neutralize. So we have right here, H plus equal to OH minus. And then up here, we have an extra amount of what? Hydroxide or OH minus, right? So that's the idea. What you could do is by reading this graph, you could take a look at the volume and get the VB there. That's one way you can get the volume. And notice I kept adding after the endpoint for this. That's important to make the graph. You are required to make this graph for at least one of your trials tomorrow. The idea is that we get 3 trials done. This laboratory is timed so that if you do everything, quickly, you should be able to get 3 trials done. How often does that come with practice? I don't know. It always seems like we're right there on the end sometimes with a few groups, right? So I mean, just think about that whenever you're thinking of what you got to get done tomorrow. Like, make sure that you pay attention to the techniques so you don't forget it. I know that with the cabbage lab, some people are like, "Oh, that's right, we use the glass stir rod," or "Oh, that's right, this," right? So please make sure. Sure. So if we take a look under the titration thing, those of you at home, one of you guys should make sure that you download this graph and copy it. That way you're not correcting the one for everybody. And that's going to allow you to, whenever they call out the numbers, to punch that right in there. This is actually a blank document that's ready to go. All they got to do is tell you the pH level. They can give you the beginning and ending OH here and here. They can tell you the pH level, and you boom, boom, boom it in, and it will make this graph right here. Just like that. It's already set up for you to make it. So that's pretty easy. I mean, it's set up. You can do it. Yeah, right? It's good. So that is the idea. What's this person? Oh, Redland's already doing it. Oh, nice. So you want to make sure that you do copy that so you don't change the permanent file. I don't know how to make it not do that. Maybe I can figure that out tonight. Like, I'm the only one that allowed to edit this or something, but other people can make a copy. Yeah. So that's going to allow you to get that ready. And the other thing you'll want to do is you'll want to download this acid titration, acid-based titration thing. Now, tomorrow we are doing a strong acid. Oh, I'm not sharing this. Hold on 1 second. Tomorrow we are doing a strong acid. So our pH break will be at 7. On Thursday and Friday, we will be doing a weak acid, HC2H3O2. We're going to find the concentration of vinegar. I've got some vinegar purchased from the store. We're going to add that vinegar to a beaker, and we're going to find the concentration of what vinegar at the store is. We're again going to use the sodium hydroxide for that. So what is our products here? What's one of them for sure? H2O, that's the easy one. And then Na will remove this H. So we will get NaC2H3O2. What's the charge of Na? What's the charge of C2H3O2? -1. So that cancels out, and we're still at a 1-to-1. So that's nice. The problem is that sodium is going to be a spectator ion here, and we are going to have C2H3O2 negative. If this is making this, guess what C2H3O2 can do? So this is a weak acid, so it's going to make a conjugate what? Base. So this C2H3O2 is a base. So what it can do is start pulling hydrogens off of this water. And as it pulls hydrogens off of this water, what is it going to end up creating? If it pulls a hydrogen off of this water, what is left here? Hydroxide, right? What's that going to do to the pH? Make it go up. So with the strong acid that we're doing tomorrow, and strong base, it will stop the pH at 7. With this, we will stop the pH, the endpoint will be at about 8 something, right? This is the reason for different indicators. If we're dealing with a pH about 8 something, which indicator do we want to use? Not that one. Big range here, probably not that one, 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 not that one. Phenol red would be nice. How about this? This one also, phenolphthalein, right? Right there at 8, boom. So it's a little bit above 8 where the pH actually starts to change. But yeah, phenolphthalein is the one we'll use for that. So that's just to show you that different indicators are needed for different situations. What if we were neutralizing a weak base with a strong acid? Well, then instead of the pH being 7, where's the pH going to be? Yeah, it's going to be lower, right? So we might need methyl red for that. Or maybe bromothymol blue again. But yeah, we're going to need different ones. So that's just something to think about. These are the different indicators. Yeah. All right. Good. So let me get everybody in here a copy of this, and then I'm going to go back to the lab and show you the important technique to make you be faster in the laboratory. Down to coconut, right? Okay. Oh yeah. He's a good boy. Cool. That's funny because the other guy was in Coach A before Coach Clark.
I would say it just took me like 20 minutes to like so then like last.
Well, we don't. The average one? Yeah. Yeah. All right, then. I don't want to stop share, put it on my face. My face. And then we're going to take a look back here in the laboratory. You guys that might want, you might want to maybe move. Maybe you can just sit back here or back there. I don't want to block too much for you here. All right, so this right here, guys, in here. This right here is $140 worth of stuff. So please make sure that when you're using this, that you are very careful. This is known as a butterfly clamp. So the way this works is you hold on to this and then you squeeze these two things like that and it releases it. Right? So this is the acid one. So I need a beaker for acid that is clean and dried. And I need a beaker for base, which is clean and dry. Tell you the truth, I always use the smaller one for the base. I don't know, it's just in my head. Notice I pull these clamps down and then I put it in there. And then I go ahead and I force my fingers in there to make sure it has it. Otherwise, I didn't do it to this one, and what can happen? It can slide. So then we want to make sure we put that pressure on there, and then it's not likely going to happen. Another failure of this is right here. We want to make sure that that is tight so that that whole thing doesn't slide. All right, so these are $70 each because they go out 2 decimal places when measuring volume. Accuracy is expensive, right? So the more accurate something is, the more expensive it is. These scales go out 3 and they're $1,500 each. That one up over there goes out 5 and it's above $10,000. It was donated to us by Roche Diagnostics. They had a lab closed down, and so basically to get tax breaks and stuff like that, they donate to schools, right? Oh, cool, right? So the way we use this is my base one. I'm only putting base in there, and as I said, I do know the molarity of this base. Actually, I got enough in there already. So I don't know who used this before me, so I want to make sure that I give it a rinse with probably 2 milliliters. There is a B on there to mark that this is the one for the base. The base should also always be on the right side, a B, as you read it. So, my glasses. But if we take a look, we put our thumb on there. I think we did this with the acid with the burette or the eudiometers, right? When we made the gas. Were we here for that? Where you guys had the port and over there? Yeah. Huh. Yeah, there's only one thing. So you're going to put about 2 milliliters in there, and then you're going to, with that end over the sink, you're going to kind of get it all around and make sure that this is flushed. This is what's called the cock. This is the stopcock. It currently is perpendicular so that it is closed. In order to make it open, we need to turn it so it is parallel. It's the same way that the gas valves here work. They're perpendicular if they're off, and they're parallel if they're on. I'm going to turn that parallel, and you're going to see that flow out. So what this does is I've just rinsed this whole thing out with the chemical I'm going to use, right? So if there was distilled water in there, hopefully it's out, it's done, it's taken care of. We're going to close that back up, and then I'm going to fill this up. The base. You just give it a nice flush with the base. That's what we're putting in here anyway. And I should take care of it unless somebody like really messed up the last period and had them switched. How much? For each trial, you need about 15 milliliters of each give and take some. So I'm going to do one trial. So I've got 25-ish milliliters in here. That's good enough for me to go. Now I'm going to do the same thing with the acid. The acid is what we don't know. And while these are labeled H2SO4, this is not H2SO4. It is in fact HCl. Oh, don't do that. So again, 2 milliliters. It's got an interesting voice, goes up and down. So we take a look, 2 milliliters again. Spin it. And again, this one has an A on it. Open it up and let it go through. All we need to do is rinse it. So if you put too much in there, you can always just tip it upside down that way. Again, same technique as before. Make sure the cock is closed. Otherwise, if there's somebody standing behind you, this happened once. Somebody was sitting there going, boop-a-doo, 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 and they're sitting there pouring it on the other person, the back of the other person's leg. Not fun for either involved, but really not for the unfortunate other person. Funny for everyone but them, right? And then we squeeze that and we put it in. So now we've got acid and base in here, right? So now let's all go together on this one right here. You can see this little example one. Now I'm going to add a little bit of distilled water here to my pH meter because I spilled it. 1, 2, I want to add a little bit of water to this acid so that it is not the same one that you guys have. It's not, this is a different concentration now than what it will be tomorrow, right? Because I just diluted it. You can also do it this way. Some people are not tall enough, though. Now,
How much of like the diluted it's on?
I did it just so it doesn't match what your concentration would be tomorrow. You don't put any distilled water in there. You go with the concentration that this is. All right, so the first thing I want to do is make sure that the cocks have liquid in them. So I need to run some out of here right away so that both of these are now filled. Otherwise, my reading there will not be the same, right? So I'm going to put those to the side. You take something behind. Actually, I can put these here and I can put it down to something. I'm at right now, it would be 12.87. I could write that down, or I can take it down to 12.37. Or I could take it to, I'm going to take it right to 13. So that's 13.00 for the initial volume of the HCl, the acid. Remember, we're on the sample one, right? Not the actual big table one, but the sample. I'm going to do the same thing to the base. Put some white behind it. Oh, wow, I don't have to do anything to the base. It's already at 26.00. Amazing. Sometimes life's just that cool. Then I've got here my beaker for collection. Want this cleaned and dried. So I'm going to start with about 10 milliliters. So I was at 13. Where do I need to get down to? 23. Boom. Because this actually measures how much goes out. So if I started at 0, and I go down to 10 milliliters have gone out. So I was at 13. I went down to about 23. I don't know. I might need to add some more acid, so I'm going to hold off on that. We said this whole thing wouldn't work unless we had an indicator. The indicator we have is bromothymol blue. Bromothymol blue. This is the stuff I made. That's the pre-purchase stuff. I want to try both. That pre-purchase stuff is a little bit old. So there's 1, 2, 3, 4. And bromothymol blue is what color?
Yellow.
Yellow, right? Actually, that looks better than the pre-bought stuff. So that is yellow. And then when does it change to blue?
Higher base.
Yes, but where exactly? Because this is important. 7, right? So we have our pH meter. Remember how you use that? You put this somewhere where you're not going to spill it. And then you put right here, this is just distilled water. What's in there? It's a potassium chloride. Basically, it protects the probe here. This probe reads through electron changes. So, what's that? Yeah, just make sure that you keep you just want to make sure it's clean. So then we're going to take that and we're going to put it in here. And we're going to take the pH of this. 1.9, let's see. Still going down, huh? Where are you going to stop? Boom. So 1.60, that's what I would have somebody put into the graph at 0 milliliters, right? So Raylan, you could put that into our graph at 0 milliliters. We could also have Raylan figure out the concentration from pH. How do we figure out hydrogen ion concentration from pH? Yeah, anti-log of 10 to the or 10 to the negative power of the pH. So somebody figure that out. Take 1.60, 10 to the negative 1.60. Good, and you are actually going to write that on these lines right here. And then Raylan or somebody else at home can determine the number of milliliters of base we should use. because we know the ma. Now, based on the pH, we know the va, about 10, right? From 13 to 23.
Wait, do we write it on the?
There's it's actually in the directions part on the front page.
Oh, I thought it.
Yeah, so we were on pH, why do we write on pH?
Well, whatever she said. What'd you say?
0.025.
0.025. And then somebody could use that 0.025 and the 0.130 at home to determine how many milliliters I should use of this, right?
It wasn't one.
It has to be in here because that's yellow, right? And that's going to turn blue. All right, so now we're going to add 1 milliliter of base, and after every 1 milliliter of base, we're going to take the pH. Somebody at home want to figure out how many milliliters this should take of the 0.13? So there is of the 0.13 molar NaOH. This is where things get confusing real quick, right? 0.130 molar NaOH. That's the concentration of the NaOH. Because it's written on the bottle. And I made it. All right, so there's 1 milliliter. We are going to take the pH of that now. And what should the pH do? Go up. So we were at 1.60, now we're at 1.75. Now we'll add more base. 1 milliliter, right? And I just said that, so somebody should be typing that into the graph at home. You don't have to today, but that's what they would be doing hopefully for you tomorrow. We add 1 more milliliter. Now we are at 1.92. One more milliliter. $1.94. So we're slowly going up. When should it turn colors? 7, right? Did anybody figure out the amount that it should turn at?
Take forever. Do it 1 milliliter at a time.
We have to do it 1 milliliter at a time, only one time, and that's to make the graph. So if it's 0.2, if it's did you say 0.25 molar or 0.025? And that's 0.13. Yeah, this shouldn't take too long. 2.05. One milliliter. Now I just saw it stay blue a little bit longer than before. So 2.30. I'm only going to do half a milliliter this time. So I'd have to change the graph. $2.35. Another half a milliliter. Oh, 2.50. So we are on that part of the curve right there. So this is probably going to change within the next milliliter. So I'm going to do half. You can see that blue is staying a little bit longer. 2.75. And the technique for when you're not bothering with the milliliter thing
is to get it like this so that you're going one drop at a time. And look right there. So that one drop at a time, that probably is my titration point. So if I take the pH now, where am I going to be? I'm going to be pretty close to 7, right? So this right here is 6 point. Yeah, 6 point. You can see. Look at that. So I might have added one drop too much or whatnot, but that's okay. You can see how quickly my graph just went boom, right? We can take that milliliter. Now to finish off the graph, now we will continue to take 1 milliliter at a time here. This is not necessary for your other trials. This is only to finish off the graph. So then we would take the pH again. And then guess what? 10.11.50. So I may have wanted to take and only do a half there after that titration point. And then we'll add another one. And we are now to 11.96. Add another one. $12.11. What's happening here?
You're about to start to flatten out.
Yeah, right. We're leveling off. Another one.
We gotta get to 14.
No. Once you see it start going boom and flattening out again, you're good. Here we're at 12.21, so I might do one more. Just for the good, you know, just for the sake of it, I might do one more. But that's it. I don't know if it's best to do the pH meter at the start of the one, or as your last one, or as your middle one. But you need one good one where you've checked with the pH meter and you've built that graph. Questions about that at all? So you would do 3 trials with that one acid. All right, so let's go ahead and calculate what the math says for this. Are you ready? This is going to be, I think, Mia, you've got these down, right? So this is going to be the final volume of the acid. 22.95. 22.95 milliliters. And the final volume of the base, oh, dang it. I didn't get it. I forgot to look when we did it. So how many extra milliliters did I go? 4. All right, so let's add 30, so it'd be 34.61. I can't believe I did that. Yeah.
Wait, what did you do? Sorry.
So whenever it turned blue the first time, whenever I did those tink tinks, I didn't check it. I forgot to record that. I should have. That would have been the final volume of the base at the end point. My silly brain didn't think of it, and it was more important to me at the time to show you to keep going on this. So make sure those of you at home, whenever they reach that end point, make sure you tell them. So Mia, now take the final volume of the HCl and subtract the initial volume of the HCl. Anybody at home got it? For the HCl, it should be about 10. It should be a little less than 10. You doing the NaOH? 13.00 minus 29 or 23 point.
Wait, 13.00 minus 22.95 would be the other way around.
Absolute value if you do that. 20, what was it? 22.9 what?
22.9.
95.
I got 9.
So 9.95 will be the volume of the acid. And how about the difference of the base? 8?
Yeah.
8.61. That's the number that we are not sure about because of that, me getting that final base. You should definitely have better patience tomorrow with that. So this is our VA, this is our VB. So we go ma va over ka. What is our ka and our kub? 1. So we can just go ahead and get rid of that on here. And the volume of the base is, actually, let's solve this for the molarity of the acid. So we're going to divide by the VA on both sides. Remember, the molarity of the base is on the bottle. 0.13 times 8.61 divided by 9.95.
It's about 0.1124.
Nope, the acid. So there would be our molarity of the acid. So you know the formula, right? So you know the molarity of the base is on the bottle. That's 0.130. This is where we got the volume of the base. This is where we got the volume of the acid. So there we go.
I don't get how it's.
So you imagine it measures how much has run out of the cock. So it's at 0.00. And if as you let it drain down, it goes down to 1 milliliter after 1 milliliter has gone out. 2 milliliters. So it measures how much you've put into the beaker.
So how much now to put into
So you should put
the initial volume?
the initial volume of the acid should be about 10.
Okay. And then the initial volume of the base.
But that's the thing. The base is what's finding the acid. Now, if you knew the concentration of the acid by using the antilog or the negative pH, you could find that concentration of the acid. Then you could solve for the VB here, right?
Yeah, but how much do you know to bring out the base?
But that's until it turns blue. You don't. You start if you're doing the pH meter, making the graph. Then you do 1 milliliter increments.
And then when it turns blue, that's when it goes to
That should be whenever you take the volume of the base, the final volume of the base. But when you're making the graph, you want to keep going after that, after you've taken that mark, so that you get that top part of that graph. Initial volume is taken right at the start.
but it's 0. So when
Well, if it's 0, if you filled it all the way up. I didn't fill those all the way up, so I took the initial volume at wherever they were. So if I fill it up to 25 and I add 1 milliliter, the reading is going to say it went from 25 to 26. So we take 26 minus 25, we get 1 milliliter. I'm going to let you go over and look at it in a second, and then you can figure it out. You'll be able to see it because it's harder to just think about it unless you've actually been up close with it. That's what I got for today. Your assignment for next for the rest of the week is to do this acid base lab. Your assignment for the day before the actually, I do see you guys on Friday, so that'll be still this. You guys should have this acid base packet, including the back review page, done by Friday probably. I will look on and maybe get another review out to you guys, but yeah, that's the basic one right now. It is only over acid base. That's all I got for today.